If you're working with a class census dataset, an outlier is a value that sits unusually far from the rest of the class. That matters because this data describes real people. A strange value might be a mistake, or it might be rare but real, and either way, it can change averages, graphs, and conclusions. Start with common sense checks before doing any statistics. Ask what values are even possible. Ages shouldn't be negative or 150. GPAs shouldn't be above the scale. Absences can't exceed the number of class meetings. In a spreadsheet, simply sorting a column often reveals problems instantly, like inches mixed with centimeters or percentages typed where GPAs belong. For categorical data, make a frequency table. Typos and one-off categories jump out right away. Next, look at the shape of the data. Histograms show whether values cluster together or trail off to one side. Boxplots are especially useful because they come with a standard rule for flagging outliers. That rule is based on the interquartile range, or IQR, which measures the spread of the middle half of the data. Values below Q1 minus 1.5 times the IQR, or above Q3 plus 1.5 times the IQR, get flagged. Flagged does not mean wrong, it means investigate. Z-scores are another option, but only when the data is roughly symmetric. A z-score tells you how many standard deviations a value is from the mean. Values beyond plus or minus 2 or 3 are unusual. If the data is skewed, z-scores can mislead, so the IQR rule is usually safer for class surveys. Outliers can also appear in relationships. A scatter plot might show a student who doesn't look extreme on any single variable, but is far from the overall pattern, like 0 study hours with a perfect score. When you find an outlier, decide what it is. Errors should be fixed or removed. Rare but valid cases are usually kept. Contextual cases should be explained. The key idea to remember is simple. An outlier is a question, not an automatic deletion.